Hi there. Welcome to problem 4 of the Essentials playlist. This is Soman and you're watching the Genesis YouTube channel. Today's problem is a past JEE question from 1989 and it goes like this. Two blocks of mass 2.9 kg and 1.9 kg are suspended from a rigid support S by two inextensible wires, each of length 1 meter. The upper wire has negligible mass and the lower wire has a uniform mass of 0.2 kg per meter. The whole system of blocks, wires and support have an upward acceleration of 0.2 meter per second square. The acceleration due to gravity is 9.8 meter per second square. Part A, find the tension at the midpoint of the lower wire, and part B, find the tension at the midpoint of the upper wire. I suggest you pause the video and try to do it on your own. This is a very straightforward question which should be doable by most students. The only non-standard part is the string with mass, rather the wire with mass, but even that isn't difficult. Do try to do this on your own. We now go ahead with the solution. To find the tension at midpoint of the lower wire, we put a mental cut at this point and draw the free body diagram of the lower portion. Let the tension at the midpoint be TLM. The wire below has 0.5 meter length and has a linear mass density of 0.2 kg per meter. And therefore we get a mass of 0.1 kg for the wire below the cut. Thus the total mass below the cut is 1.9 kg plus 0.1 kg. 1.9 kg for the block and 0.1 kg for the wire below the cut. That gives us a total mass of 2 kgs. The total weight acting downwards is therefore 2g. 1.9 g plus 0.1 g. So the equation of motion can be written as upward force minus downward force is equal to mass into acceleration. TLM minus 2g is equal to 2 times A. So TLM is 2 times g plus A. Substituting, we get the value of TLM as 20 newtons. Similarly, to find the tension at the midpoint of the upper wire, which we need in the part B, put a mental cut at this point and draw the free body diagram of the lower portion. Proceed exactly as we have done before, and you should be able to see that the mass below this point is 5 kgs. And therefore, the equation of motion is TUM minus 5g is equal to 5a, where TUM is the tension in the midpoint of the upper wire. So TUM becomes 5 times g plus a, substitute the values, you will get 50 newtons. And therefore, the answers are part A 20 newtons and part B 50 newtons. I hope you liked the problem and the solution. Keep watching the Essentials playlist for more such problems that every physics problem solver must do. JEE aspirants can also watch the Solutions to JEE Advanced 2020 playlist. We also have a playlist called Problem Corner in which we discuss unique problems with ingenious solutions. And finally, if you like the content, like, subscribe and share widely amongst your friends. Till the next video, stay safe and stay healthy you all.